Hey, welcome back to Detection at Scale. My name is Jack. Today, I'm here with Charles Anderson, who is the director of the global SOC at one of my favorite companies, Sony. Hello, Charles.
Hey, Jack. Thanks for having me.
We were talking about how I'm a Sony fanboy before we started, and I used to be a photographer. I was like a very avid Sony photographer, and I always thought that it was incredible technology. So it's cool to meet someone inside the company that I've been a fanboy of for many years.
Well, it's always cool to have the conversations with people who love the technology. And that's one of the great things about working here. There's so many different cool things we have a hand in. So
yeah, you said something about cars.
we're dipping our toes into EVs with Honda. So there's a joint venture that y'all can read about, and some concept cars out there already that we've been showing off. So it's really cool to just even think about getting an opportunity to work on the security of the companies involved in that if that gets to happen. So
that's super exciting, and we'd love to see more EVs. I'm also an EV fanboy, but it's great to have you on the show. Would you mind giving just a quick background on yourself, what you're working on now?
Sure. So for my background, did a lot of, government and private sector consulting, DoD, civilian government, global kind of policy organizations, things like that. And when I was there, I was focusing primarily on digital forensics, incident response, a lot of cyber hunting, catching nation state actors, kicking them out of networks, and then building programs and capabilities to keep them out. And that really kind of informed the core of my security career. But I've done a whole bunch of other things, in the blue teaming space, auditing, vulnerability assessment. And I've done a lot of dabbling in the past with software development and code and things like that. But kind of computers and kind of security have always been part of my life. And I love tinkering. I love learning. So it's a good fit for our profession.
And tell us a little bit about Sony, your work there, what you're in charge of, things like that.
I run the global SOC. So Sony's a truly multinational conglomerate. We're practically we have companies in almost every industry vertical in almost every country. So really, really narrow scope for our threat intelligence team to be tracking the landscape on. I say that with a little bit of sarcasm. The scope of that work is really, it's incident response, it's detection engineering, it's threat intelligence, a little bit of vulnerability management, and digital forensics, and all the things that kind of go along with that. Malware reverse engineering, a little bit of security engineering as well. And we do that for all of the hundreds of companies in the Sony group.
That's probably a big responsibility, and I'm really excited to pick your brain and get some learnings onto the pod. Before we hit record, we were talking a little bit about the risk-based alerting approach, and you had some really, really great, interesting thoughts there. So why don't we start with that? Risk-based alerting has been a thing a lot of people have been talking about as this progression in SIM. So I'd love to hear how you think about it in a more practical way.
Risk-based alerting is challenging, I think, for a lot of organizations to get their handle on. But the way we approach it is, we track all of the detection content we build at different layers. So we have things that, we call them something like risk modifier, just interesting facts about, an identity or an asset that we would never ask an analyst to investigate on its own. But if they're already looking at that, device or user, it's potentially interesting context for their investigation. And then you have like a next tier up, which we call our low fidelity detections. And those are things that are definitely worthwhile looking at in terms of an investigation, but by themselves, we wouldn't trigger an alert, but maybe with other low fidelity indicators, it's worthwhile for triggering a human to look at that. And then on top of that, the top layer, we have our high fidelity detections. And those are the things that we always think are worthwhile for someone to look into. But we were also talking earlier about this concept of the importance of the metadata you track about your detection content can be leveraged to enable that risk-based alerting approach. So, everyone's familiar with kill chain and attack, but we track that for every piece of detection content we build, and that's in a database. So as all of our detections trigger, we can then say, look at, all of the low fidelity alerts for all of the assets and show me the ones that have like 3 or more sequential kill chain phases. And that already is far more efficacious than a number of other approaches. I think probably the first approach a lot of people take with risk-based alerting is they assign like a score to these lower fidelity alerts and they say, hey, if this identity gets above a 10, then we're going to trigger something. You pick an arbitrary number. And that approach of just kind of stacking without context doesn't really result in high quality detections in my experience. So the more kind of context you have about your detections, the more you track that in structured ways that you can use in your detection content, it really kind of enables this kind of whole new approach to things.
So instead of it just being this additive sort of system where each signal it increments by 10 on the identity, you're more interested in looking at things like kill chain sequences. Like, are there other parts of that as well that you would categorize as like sort of a better method of doing risk?
You could obviously kill chain sequences, attack framework, like specific AFIDs. If you can build in specific business context for assets and identities into your data sets or objects, whatever you want to call it, that context can be really helpful as well. But the challenge is tracking all of that becomes complex, and you also need a way to do it that's structured so that your detection code can consistently reference it and incorporate it. There's potential for it to get very challenging to track if you don't have a good structure and a good plan for how you're going to do it.
You use the acronym I'm not familiar with, AFID. Is that a MITRE thing?
Oh yeah, it's a MITRE thing. It's the attack framework ID for
of course
specific technique or sub-technique.
I also want to call out the fact that you didn't even say MITRE, you just said attack. And I thought that was so representative of like the DC culture of like federal government. And I was like, yeah, in the Bay Area, we say MITRE because no one knows. Like, if you don't qualify it, but because it's so ubiquitous there, I just thought that was kind of a funny thing.
Yeah, guilty.
I think that's your background, right? Like you've been out in the DC area for some time, right?
Yep. Grew up here and I've been working here ever since I started my career.
It's a really great place to do security as well. It's actually where I started. I worked out there, really close to Dulles as well. And I moved out to the Bay Area and then got more into tech and software companies. So it's funny, the dichotomy of where these big security hubs are. And I think there's a lot of folks in the Bay Area who certainly subscribe to a lot of what you're talking about, but not so much with like the federal government sort of lens. But in reality, it's like the federal government and defense is like so synonymous, right? Because Homeland Security and nation states and all those things. So it's probably a very different mindset there than it is in Silicon Valley.
I would say probably like 15 years ago, that's true. But I think since then, a lot of the people that I kind of came up with in that kind of contracting, consulting, and just like direct work, we've kind of all moved out into the commercial space. And so it's interesting as I look at all like and talk with my friends who are now at all like the FANG companies and all that stuff. It's interesting to see how our kind of approaches have been affected by that more kind of commercial way of thinking about things and how we've had to adapt, but some of the things that we've kind of brought with us. But not to say that one approach is right or wrong, but there's definitely, like you pointed out, it kind of colors perspective for sure.
Sure. It's probably not a coincidence that some of the best security forces come from government, right? Like I think Israel is a perfect example of that. Like you can name so many companies that are ex-IDF folks. And it's just because that's a culture that's created within the government to protect the homeland. And then a lot of those people are like, well, it's also applicable in commercial. So I think the lens you get from that is certainly really powerful and really contextualized versus if you go from building software to doing security, it's okay. I think you don't really get it as much. It's harder to sort of bring people into the fold of like how to think like a defender, right? Versus if you come from law enforcement, which I think is also very adjacent, right? Like doing like e-crimes. Like I worked with like a team at Yahoo who did a lot of e-crimes work, and that's their world, like federal government and like taking down like people all around the world is insane, right? Like it's insane to watch how much stuff happens every day. It's really interesting. It's good. It's cool that you had that experience and now you brought it into commercial. I want to pull a little bit more on the thread of RBA, risk-based analysis. A big thing that I always think about is like, how do you determine thresholding, right? Is like, is it static? Is it non-static? Is it just the algorithm has to be good enough to just determine it and you're smiling and laughing? So I'm assuming you have an opinion about it. But I always think about that question. Like, what are people's tolerances for things like this?
Thresholding for me, it's super challenging. And it falls back on this general idea of, scoping what's acceptable within a certain set of criteria. So it's really complicated to think about because for me, you're considering the risk tolerance of, the specific platform or environment you're monitoring. So that's gonna impact, what an acceptable threshold is. There's, how your analysts feel about things, although ideally you never use that as a primary gauge for limiting your detection content. And there's what the business needs and what the active kind of threat landscape looks for the environment. And you have to try and figure out a way to balance all of those things. And those variables can change. I mentioned, we're in a whole bunch of different, industry verticals, hundreds of companies. Those variables can change across companies. So balancing all of that is something we attempt to do on a regular basis.
Do you think that there's a pretty good intersection or middle of things you're just looking for everywhere? Like, is it like 80-20 where you're saying like, okay, we're looking for the same 80% of things everywhere. And then for certain verticals, we specialize, or is it more homogenous than that?
Making up numbers here, I'd probably be more comfortable in the 60 to 70% range with the rest being variable. But there's just so many factors.
That's interesting. I mean, that makes your job a lot harder, right?
Yep. It's trying to find those commonalities. And when we're managing this corpus of detection content for all of these companies that have, very different ways of operating, we have to make sure that, one organization's exceptions don't impact another's, one organization's risk tolerances don't impact another. And so balancing all of that is a constant struggle. Like we do far more detection, tuning, and modification than development and deployment, like significantly orders of magnitude more to keep up with just the complexity of the organization.
I think this is a great segue to talk a little bit about detection capability and things like that. And it's very, very adjacent into the risk-based world, and they sort of go hand in hand with one another. But one thing I'm really curious about is with that level of variance in environments, do you rely more on like machine learning style things? Do you rely more on just like interesting correlative rules? Is it kind of a mixture of everything? Like in a world where it's not homogenous, I can imagine there's probably a lot of interesting tips you've picked up along the way.
It's interesting you mentioned machine learning because I think that a lot of security vendors, they'll bring machine learning models to the table and they'll try to apply a single model to an entire organization. And for us, that doesn't work because there's so many different unique ways of doing things that it just typically doesn't track. So like some of the big, machine learning detection sources we have, we actually end up layering on like baby's first machine learning on top of that to whittle it down to things that are more efficacious, higher quality. And it's kind of funny. Like whenever we talk about like layering on machine learning, we're not doing it with like this super, strict data science approach. We're detection engineers with threat background, good DFIR understanding, good data understanding, but we're just trying to, make it work and balance all the factors.
That's funny. Baby's first model.
You gotta be humble about some of the things you do and be willing to step back and say, hey, this simple approach is actually very effective. And because we're consistently measuring and tracking the performance of our detection content, we can quantify that and point to that. Mm-hmm. And sometimes it's not worth investing weeks and months developing complex algorithms that are very, very complex to maintain and care and feed over time. Sometimes, that simple approach is good enough.
Yeah. The thing that I thought about when you were explaining that is my naive assumption, maybe because I haven't been a real defender in a long time, 5+ years since I've been running a company, but my naive assumption is that most attacks are like smash and grabs. They're like not very elegant. It's like really obvious. They're doing a lot of like dumb, noisy things versus the super advanced nation state hackers who are like laser focused and super sophisticated. I feel like one is more geared towards what's common and what SIM is more geared for versus what you would want like a EDR vendor to be great at, like I'll call CrowdStrike out just because it's like kind of their bread and butter, right? Like detecting those styles of like host-based compromise. But to me, it feels like you don't really need crazy ML stuff when you're looking at the grand scheme of things because of how unsophisticated most attacks are. Do you think that that's a fair assumption?
Yeah, definitely. I think like my background, I mentioned I did a lot of like DFIR, breach response, cyber threat hunting. There's like a 5-year window, probably 2008 to 2013 timeframe where I was in the thick of it, hunting for nation states. And that experience was fantastic, taught me a lot, built this sort of muscle memory around that. But the reality of a lot of stuff that's happening today, it's, you have an accidental exposure of infrastructure to the internet. There are folks out there who are scanning for that opportunity, and organizations become targets of opportunity more often than they become targets of, specific intent. And that's the vast majority of it. It introduces this whole other risk awareness and mitigation element to the detection philosophy, where, but we're not just only thinking about what are the threats we can detect, but what are the risks that we can detect, or the state changes in our environment that introduce risk that could then lead to exploitation of a threat. And how can we identify that and quickly, help remediate it, or call to action for the folks in charge of those systems and environments.
ML models are interesting from a behavioral perspective, or maybe like an outlier analysis or kind of something like that. Like there's probably like good legit use cases of it, but I think something, going back to this concept of primitive is probably better. What about just using past behaviors in a simpler way, right? It's like we have this big corpus of information. How do we incorporate that into like our rule sets? Because I feel like a lot of people just think about it as like point in time, but I haven't heard a lot of people talking about like, oh, it's like point in time and past and sort of combining those concepts. So, I mean, are you actively thinking about using your corpus of logs in more interesting ways that may not just be like modeling, not machine learning modeling, but maybe like more primitive things that are useful?
Yeah, definitely. There's some concepts, like if you're familiar with the concept of like prevalence for certain data sets, like I think that's kind of along the lines of what you're talking about.
Yeah, exactly.
Like how often are people communicating with certain email domains that might be interesting to inform your BEC detections, or it's very, very challenging to do that effectively. There's definitely a lot of options there. It just depends on what rabbit hole you want to dig into. And again, for us, we run into this challenge of, scoping and finding an effective set of contexts within an environment we want to monitor that will enable good quality detections for that environment. And again, making sure one part of the organization, their risk tolerance, the way they operate, and how we tune detection content for them doesn't impact other parts of the organization.
So let's talk a little bit about tuning and things. And I have another question too around like what you gauge as good and bad and things in terms of rules, but I guess just more primitively, like how are you handling all the permutations of tuning and like where's your logic living, like those types of things? Like what's your methodology for rules and such?
From a tuning perspective, then when we first built our detection program, we were trying to keep it as simple and not complex as possible. And we tried that approach for a period of time to keep things more manageable. But from efficacy perspective of our detections, it didn't really allow us to specialize in the way that the business has needed us to kind of meet them where they are at. So what we ended up doing is kind of taking a couple different approaches. One is, we build our baseline detection content, kind of your base condition, if you will. And then we may break that out into a few different pieces of content that have different scopes. So a scope could be a company, scope could be a region, scope could be a specific application. And then within that, we can then layer on tuning. So we'll sometimes do tuning directly as part of the piece of detection code, but we also layer on additional layers of kind of checks and enrichments after the fact. So yeah, we have this base piece of content running, and we have a piece of code that knows to check this kind of master tuning database and say, hey, okay, these conditions are met by this alert, but let's check the tuning database and see, hey, is there additional context here that means it's worthwhile or not to actually trigger something for a human to look at.
It's interesting. So you basically create derived rules, so to say, right? Like you have your baseline, then you have like the version of it for this environment, the version of it for that environment.
Yes, you said it much more succinctly and concisely.
And then when you think about tuning, are tuning like suppressions of like, okay, this is a thing we just know will always happen and it's okay? Or is it more of like we're refining the logic, or is it a mix of both?
It's definitely a combination. Whenever we tune things out, we try and make it a risk-based decision for whoever has the responsibility to make those. I think a lot of times, incident responders want to just, hey, this is noise. I feel like this is noise. Let's tune it out. But we try to make it a deliberate risk-based decision and tied to documentation so that we can justify, hey, if we ever miss something as a result of that, decision, we want to capture it, we want to know it, and we want to learn from it. It's fundamentally similar to having like a change management process for your IT system. You want to be able to track the change and understand why.
And are you all using some detection as code methodology, or it seems like you're declaring things somehow? Is that like a homegrown thing? Is that something open source? Just curious. I don't know if you can say. If you can't say, you can tell me, Jack. Super secret.
No, like we're just basically stitching together GS14 classified, not even a real thing. But we're stitching together a combination of different vendor technologies, like our SIM, some of our data lake components, some of our code tracking platforms like leveraging like Git under the hood, ticketing systems, and then like custom applications or custom kind of data objects we built within our SIM and data platform to enable all of that. And it's more about having like a consistent, we have these data structures we've created, and we have documented ways that we use them to track and interact with our detection content. And we manage all of that. As part of an overarching threat detection program.
Yeah, that's super interesting. So you said something earlier around performance, and I was really curious on how you just gauge this in general. So like, how do you know that your program is in good shape? Like, what are you tracking? What are you looking at? And how are you trying to improve that over time?
There's a number of different ways you can look at it. An interesting concept that I got turned on to a few years ago is if you think about your detection content as classification algorithms, then there's a whole host of knowledge from the software engineering industry, years and years and years, of how to classify and grade the quality of those algorithms. So we take that approach, but at the end of the day, it's what your leadership's going to care about is time to detect and how many incidents that we know of are attributable. Is the detection attributable to your detection program? And we want to keep that high. We want to keep that above 90%, because the worst thing you can have is a false negative.
So I have beef with time to detect because I feel like it's not within the control always of the team, right? It's like time to detect, you're kind of at the mercy a lot of the infra. So it's like, how can that be a metric that you improve? You know what I mean?
So we track that for every single piece of detection content individually over time. Mm-hmm. And I think that it actually enables you to tell the story of the things that you are missing to do your detection engineering job effectively. If there are delays in log delivery or incomplete information, like if you have a structured approach to documenting how you do your detections and this kind of metadata around the detections, you can really build, it enables you to build that picture to, if it looks bad, you can explain why. And I think I've been very fortunate to be part of organizations where the approach is very much, if there's some sort of, failure or issue, be able to explain it. And if you can explain it and demonstrate how we're going to be able to improve it, that's the most important thing. Like if you're going to fail fast and fix it.
Never waste a crisis. That makes a lot of sense. I think if you look beyond atomic rules, then time to detect makes a lot of sense, to your point of incomplete information, correlation, doing some other interesting patterns there. I always think about it as like a latency thing, because if the system in real time can effectively do most of the analysis, then you're not really at the mercy of the system. It's more of the mercy of how long did it take the data to get to you? And it's you can't really control that always.
Yeah. And the other thing to keep in mind is, there's this saying there's lies, damn lies, and statistics. So these things are just, numbers. And regardless of how you feel about them, it's helpful to measure them consistently, draw a line and say, hey, this is the target. Did we meet it or not? Why? And so that gives you at least, something measurable that you can improve upon and potentially try to make changes to what you do to affect.
We didn't talk anything about fonts, so maybe let's use some time to do that. So talked a lot about detection, risk-based analysis. Talked a lot about detection, actually. It was really cool. What about automation? What percentage of alerts should be automated? How many alerts should we even have anymore? I think we need to stop the narrative of we're overloaded with alerts. I think we have enough tools now to solve that problem, but I'm curious how you think about it.
Ideally, you want to, when it comes to automation, I think you got to break it up into enriching the detection content that's produced and then taking action on it to mitigate or contain a threat that's active in an environment. So from an enrichment standpoint, that's probably, I think, one of the biggest values of a SOAR platform. And I think that before, those capabilities were more widely available, a lot of detection engineering teams that I've talked to and have experienced are trying to build as much enrichment content into their detection correlations to enable a fast analyst decision. But that has a consequence of increasing the complexity and challenge it to manage that detection content. When really that enrichment data isn't used as part of the original detection logic. So with SOAR, you're seeing this opportunity to split those two things up and allow detection engineers to focus on their core detection engineering program. And then the output of that kind of falls into this pipeline of enrichment of those alerts with that additional context that the analysts need to make a decision. Things that they would traditionally go, okay, I'm going to check this data source. I'm going to check that data source. And based on all these things, I'm going to make a decision. We want to eliminate all those pivots and data collection points as much as possible. So I think that's the enrichment side of it. And that the action side is really interesting. You want to do it as much as you can. I think it's kind of interesting given the popularity of AI and a lot of conversations about how that's affecting technology. People are talking about connecting, AI, models to action mechanisms and to, automatically detect, triage, identify, and then contain something, take some sort of action to do that. And I can't help but be reminded of a friend's AI presentation he gave at RSA a few years ago, where he kind of highlighted, hey, this was done in a movie one time. It was called Skynet. And it didn't do so well because they didn't understand what actions the machines would take. And I still think that the more kind of horror stories we hear about AI models behaving in ways that either can't be understood or explained by the people who manage them, that's kind of an interesting area to think about.
You don't want the LLM to just go take machines offline for you automatically? That sounds great.
Maybe. We'll see.
See how GPT-5 is.
Cautious optimism is the name of the game.
Of course. I'm glad we made it towards the pod and we used the word LLMs and AI. I think we can pat ourselves on the back now. I mean, I've found it really interesting from a pattern perspective and from a just save me the Google time perspective with security. I think there's some really cool places that LLMs can play a role. And
Absolutely.
it's definitely, I think going back to our combo about the ML models and things like that, I don't think it's so much like the LLM found this nation state hacker, right? It's like, no, it's more of like going to help me pattern match and help explain a log event to me or something like that. How have you all been, or how have you been thinking about it? Like, have you applied it practically yet?
Yeah, absolutely. That use case you just described, from the detection side, when you're as large as we are, we have like two of everything. So when our detection engineers are, encountered with this kind of weird application, they're given this 300-page administrative guidebook that says like, hey, build detection content that protects this thing from threats. It could be really helpful to feed that into something that you can just then ask kind of some pointed questions, and that can at least be a starting point of efficiency. So you can get an idea of, what are the types of data elements in here? What do we have to work with to kind of bootstrap that detection hypothesis process before you can get in there? And then obviously from the response perspective, there's so many different, pieces of software out there. I've seen good use cases for it around understanding where certain artifacts, log artifacts may exist on a system for a certain application that's very obscure. I've seen good use cases around, like you mentioned, just simply interpreting a log correctly. That's really exciting. It's going to make that sort of analysis and those sorts of analysis outcomes more achievable more quickly for a lot more folks.
It's going to save a lot of time and headache and headspace, and then we can focus on more important things. And I think that's really the promise of AI in general. Right?
Yeah, focus on making good decisions and less on memorizing kind of
user agents.
Yeah.
I just realized that on Zoom it says Chuck. I didn't ask you if you go by Charles or Chuck, so I'm gonna just call you Chuck from now on. I'm just kidding.
That's fine. I go by both. My dad goes by Chuck. So I have no stigma against the name, but within the Charles community, there is a bit of a stigma against being called Chuck. And fun fact, when I started at Sony, I had this huge room in the SOC. They literally sat me right next to the only other Charles in the organization. So we quickly had to decide who was going to go by what, and the other Charles was very adamant that he would not be called Chuck. So
that's funny. I didn't realize there was a community, but maybe see what the Slack channel is all about.
Have mailing list, Slack channel, all of that support group.
A lot of people on there. Well, Charles, this is super fun. I really enjoyed the time. Like every show, I always end with 3 pieces of advice. So what are 3 pieces of advice that you can give to folks listening in who are either in similar positions to you or working in teams like yours?
I would say, don't lose sight of risk in pursuit of threat. I think that threat is, and understanding threat is kind of the coolest, most eye-catching thing for us. That's what we want to dive into. But the ultimate thing that we are doing is mitigating risk for the business. So keeping that context in mind and being able to communicate in that way will help you justify all the cool stuff you want to do from a threat perspective. I would say also a good friend of mine, Ryan Kovar, gave a talk a few years ago about career progression. And one of the key concepts in cybersecurity he said was, think about your career progression not as like a ladder or something linear. Think about it as a matrix or in buckets. You're doing different things. There's very few people that I know at the stage of their career that I'm at have taken a straight line. Like I mentioned, I did audit work and VM work, and I started doing SOC work, and then I left that for a while. And then maybe 6 years later, I came back to DFIR, breach response, threat hunting. So it really is valuable to get a lot of different experience within the cyber and information security realm, regardless of what you want to do. And then I would say, lastly, if you're a technical person or individual contributor moving to a management focused role, your analysis engineering skills are going to be a very useful foundation, but your job is fundamentally changing when you become a manager, and you have a whole different set of responsibilities. And just because you're the best security engineer or analyst doesn't mean you're automatically going to be a great manager. So that's a mentality shift that you really have to take. When I transitioned to management, I had to work on a whole new set of skills to enable that because, as coming from an engineering analyst background, your inclination is to jump in, help solve problems and do that. But no, it's not, that's really not your role anymore. Your role is to enable others to do that. So that was a pretty important realization for me when I came to it. So hopefully those are things that are useful for the audience.
For sure. And the last thing I'll say on your third piece is I almost feel like managers should be relabeled as coaches. Because then it makes you think about the role better, right? Like you're not telling people like anymore, like you're not taking what's in your head and just telling it to people. You're more of like, how do I help grow you, right? Like, how do I make you the best version of yourself in this team and in this company? And how do I ensure you're successful? Like that's the job of the coach.
Yeah.
Manager is always seen as just like, you're trying to put people in the box type of a thing. So yeah, I resonate a lot with what you said. It makes a lot of sense. Well, thanks so much for the time. This was a great conversation and I'm really excited to listen back to it. I got really inspired from it. So thank you so much for your time and thank you all for tuning in.
Thank you. Really appreciate it.